Muy bien, nuestro siguiente expositor, Mark O'Brien. Mark, are you there? Right, excellent. Bueno, voy a presentar a Mark. Mark nos va a hablar de los impactos de la inteligencia artificial, qué hacer y qué no hacer al respecto. Interesante experiencia esta. Mark actualmente se desempeña como gerente de transformación digital en Citic Pacific Mining, la operación de mineral de hierro de magnetita más grande del mundo y la mayor inversión en el sector de recursos de China fuera de la China. Sus responsabilidades cubren el compromiso estratégico con el negocio, el liderazgo en la entrega de soluciones tecnológicas y la propiedad de las plataformas de infraestructura y aplicaciones clave en CPM, tanto en tecnología de información como en OT. Tiene experiencia en tecnología minera por más de 30 años, graduado de la Universidad de Curtin con una licenciatura en Matemáticas y Ciencias de la Computación. Mark es presidente del Grupo de Trabajo de Inteligencia Artificial en Minería de GMG. Así que démosle un fuerte y caluroso aplauso de bienvenida a Mark O'Brien. Mark, welcome.
Thank you. All right. Well, I have the special honor of being the first English-speaking presenter, so I'm not sure if that'll be better or worse, but it's definitely better than me trying to speak in Spanish. So, let me say it's my first visit to Lima, so I'm enjoying it very much. I think I've been here only maybe 48 hours, and I've already put on 10 kilos. You know, just eating all the good food. So I'm enjoying it very much. So I didn't quite understand all of the introduction of me. It sounded much better in Spanish, I'm sure, than in English. But there's probably three things for you to know about me. One is that I am part of a mining company that's a magnetite miner. I run the technology group, and so a fair bit of experience in the mining space. I also am the deputy chair for GMG, which is a group that's trying to make I guess, more inroads to operating here in South America, in Latam area. And so definitely happy to chat to anyone who wants to know more about GMG, because it's an organization that's very much about collaboration and working together on important topics for our industry. And so that's a key thing, and lots of opportunity. It's easy to be a part of, and we're looking to grow it. So if you want to talk to me more about that, please do. I say that also in that I think part of the introduction had mentioned that I also helped to spearhead the first working group for GMG that was kicked off to tackle the AI in mining topic. And we've been hearing lots about AI this morning. So I wanted to tackle the AI topic in a slightly different way, very practical, I suppose, because I think one of the things that we discover with AI is that there's plenty of misconceptions. Now, I will apologize immediately for my slides, because my friends say that I have a very strange sense of humor, so you will either find my slides funny or make no sense at all. That's okay, okay? But a number of years ago, I went to live in the US for a few years. And, I'm from Australia, as I hope you can tell. And, one of the things that we both speak English, but it's a different kind of English. My first evening in the US, I went to the shops to go buy some groceries, and I got all my stuff, and I went to the counter to pay, and the young man by the counter, he did all the, bagged all the, was getting all the stuff ready, did it all, and then he said, "Paper or plastic?" And I looked at him and I thought, "Plastic." Well, actually, I didn't. I said, "Visa." Because, paper or plastic, I thought he's asking me how to pay. And so he said, "Paper or plastic?" I said, "Visa." And he said, "Paper or plastic?" I said, "Visa." He looked at me like I was stupid. Paper or plastic? I took out my wallet. I took out the card. I said, "Visa." He held up the two bags, right? Paper or plastic? And I'm like, "Oh, I'll just take plastic, thanks," because here we are speaking the same language, but just not the same language sometimes, right? And one of the things I want to talk about with AI is that sometimes we say a lot of things and we're not very clear about what we mean. And there's some misconceptions for sure. And I think what I'm trying to do in what I'm going to be talking about today is really address three groups who probably usually in front of me, there's three sets of people. One is vendors, the people who sell a lot of these types of products to us. And I think it's very important that vendors are speaking the right language to customers around AI, that we set the right expectations, and we're not confusing people or maybe overselling what we have to offer. That's an important thing. Another group of people who might be here are people, say, in a mining company, and we've already had some great speakers who are people actually doing the work. They're trying to build some AI solutions. They're trying to find ways for AI to be very practical in their space. And so they also need to be on the same page as the vendors, make sure they're understanding the vendors properly. But there's a third group here, sometimes that's also an important one, and that's senior management. These are the guys who write the check. When the guy who wants to do the work goes to the big boss and says, I need X number of dollars because I want to go do this cool AI thing. And the vendor tells me it's going to make coffee and do all this stuff and it's going to be so great. And the guy at the top sits there and he goes, look, I've been hearing AI, I'm not sure. But so you got you can quite often have these three different perspectives of this thing, right? That sometimes are not accurate. And I think it's quite important for us to get ourselves on the same page, so that we can actually be clear and we can actually get good results. Because I think AI actually has a huge amount of potential for us, but we need to keep some things in mind if we're to see the best benefit. Okay, so I want to give you very quickly, six key, things for you to keep in mind when you want to tackle AI in any space, but particularly in the mining space. Okay, and we'll go really quickly because I'm quite sure that. I'm hoping some of what I say will spark some questions, so we'll see how we go. So the first thing is, don't overreach, okay? By this I mean have realistic expectations about what AI can do. Now, we live in the world where it's AI, ChatGPT is going to do everything for us, right? And I want to say that we need to be careful about this because actually some of the things that we see and we read and we hear about the technology is not entirely accurate, okay? AI definitely has some huge value for us, but only if we have realistic expectations. Now, I'm very old. You may not be able to tell it, but I managed to study AI way back when AI was first kind of making one of its big, boom times a long time ago. Back in the 80s, I'm scared to say it because there's probably some people in the room who weren't born in the 80s, but anyway. So back in the 80s, AI was just making its first real big wave. There was a lot of funding, but yet it did not meet expectations, and it went into what we call an AI winter, where it all just disappeared for a while until it came back in the 2000s. And the early 2000s, we began to see AI picking up speed again. But it was very different to the AI that we saw in the 80s, okay? When I was in the 80s working on AI stuff as part of my undergraduate studies, I was working on natural language processing, okay? This was all about trying to get the computer to understand language. Really understand it. When somebody says something, we were trying to get the computer to go, okay, the subject, the verb, the object, for, those of you who've learned language, you know what this means, to learn a language. Most of the people in this room, I'm very impressed by the fact that you're all multilingual, and many of you speak multiple languages, so you know what it's like to learn a language. This is what we were trying to teach a computer to do, and we failed. We were not able to do it very well. But some things changed, okay? When we hit the 2000s, some stuff changed, and this is actually important for you to probably just understand some of the context here. One of the things that changed was we had an incredible uplift in computing power. So suddenly, the computers that we were using back in the 80s, that were not able to process things to the level that we want, but come forward a bit of time and suddenly we have computers that are exponentially more capable. So we saw some significant things happen that really allowed us to do much, much more, okay? The second thing that changed was, and this is a very important one, is that we narrowed our expectation. We began to focus on machine learning, okay? And machine learning is a part of AI, but it's much more narrow. much more specific. It's based much more on maths and statistics, and we'll talk about it in a bit, but lots of data. And so when you have a lot of data and you're able to process and do some very smart maths and statistics on this, you're able to do some stuff that will infer some interesting results. So if we talk about natural language processing, for instance, today when you open up your Google Translate or something like this, Google does not actually understand what you're saying. It has no idea. When you punch in some words into Google, it takes these tokens and it goes back into all this data that it's processed, and it says, you know, I've seen 100 million occurrences of these things. I don't know what they are, but I know that when I see these, I give you this. And it's pretty close to what you would expect back. Does it understand what actually happened there in terms of really understanding the meaning of those words? No, it does not. It's very important to understand. It does not. In fact, one of the big criticisms a lot of people say about AI in the current age is it's not that it's too clever. It's actually that it's too dumb. Okay, because it doesn't really understand this stuff. So we saw a change in computing power. We saw a change in mindset of what we were trying to achieve. We weren't trying to make the computer understand the language. We were just trying to get enough data together that we could do some transactional stuff that was very clever, very fast, and could produce some excellent results in a very narrow space. The other thing that changed too was more money. Okay, in the 80s, all the money came from defense and government. And when there were no results, defense and government stopped paying money, and everything stopped. But what we saw in the 2000s was a change, right, where suddenly companies were starting to use AI in very simple, small ways. They were taking machine learning things and they were just accomplishing little success pieces that were actually valuable, that actually added value, and they made them money. And so we saw that AI suddenly became commercial. And so the rise of your Facebooks and your Amazons and all these companies, they use your data. And they collect it all, and they're able to take machine learning and do it, and then they're able to make money. And so the money now became much broader and much deeper. And if you take a look at charts of spending on machine learning and AI, it's just astronomical. But it became very commercial, okay? So here's some things that have changed in terms of the context of what we mean by AI. I tell you all of that to say we need to be realistic about the expectations we have. And I say don't overreach. You know, if you're talking to a vendor and they're telling you all this crazy cool stuff, you know, you really want to check that out, because some of that may not be entirely accurate. And it's interesting to me how many people really don't understand the technology very well. And so, you know, it's AI this, it's AI that, but you know, if you really dig below the surface, and I really recommend that you do, there's a lot of good books that you can read that just give you a little bit of an introduction to understanding this. If you have realistic expectations, you can get some incredible results. If you have unrealistic expectations, you will spend a lot of money and not get good results, and that's not a good outcome. So that's my first thing to say, is when you're dealing with AI, be very careful. Don't overreach. Have some very focused goals and tackle those, and you will see some good outcomes. We can talk more about this if you've got questions. The second one is, and this is a lesson that's a pretty important one, is don't underestimate the gap between proof of concept, POC, and production systems. What we've discovered in our own business is that it's really easy to give somebody a big pile of data and say, can you build a model and make something cool for us? And they can do that. You know, they take the data, they build up some test sets, and they try it, you know, and they work it all out, and they build a model, and it's like, okay, we can do this. Look at this. This is very cool. And then you sort of say, okay, but how do we now take that and make that a production system? That is much more difficult in most environments for a range of reasons. A lot of that is that, you know, you've really got to now figure out how do you create data pipelines that will, you know, be much smoother and require less manual handling of some of the key inputs that need to happen into your AI type solution. How do you sort of create outputs that are useful to people in your business? Because, you know, when you look at a model and it's got some predictive analytics that are happening, how do you take that and actually make that very useful for the people who are working in your company? And mining is a very pragmatic business. You know, you've got people who are digging dirt and doing a very straightforward job. They're using a lot of technology for it, and they want stuff to be simple. They want it to be easy to understand. They want to know what this is meaning and how we take it and we use it. And so there's a big challenge here. And I see this quite regularly where people will go, they'll get something, they'll build a proof of concept, some kind of trial, and it goes very quickly, quite well. But then the jump to take this to an operational system is often more complicated than you think. And so I guess what I'm saying to you is don't underestimate this, because this can catch you off guard if you're not aware of this. When you now want to take this and actually make it usable in your company, it can get kind of tricky. The third one that I want to mention to you is that these systems, they're not set and forget systems. Okay? They're not the kind of system you build, you deploy it, then you walk away and everything's going to run terrifically now forever on, right? It doesn't work that way. The nature of the way these systems work with a lot of data coming in, and then you're starting to use this data to now change the way that you operate in some particular arena, that then begins to change some of the outputs and what's happening, and now you've got new data that could potentially change the model. You know, you've got new inputs that are coming in now that maybe have an impact. This is one of the things that with ChatGPT people are starting to think about, right? Because ChatGPT, all that information that's out on the internet, it's using this to build its model on how to give you answers. But everyone's putting more and more content built by ChatGPT on the internet. So the next time that they refresh the model, they're going to be using information that comes from ChatGPT as well, right? So this stuff gets actually quite complicated, and it's not set and forget. It's not the kind of solution like we have in a lot of areas of our businesses, where we just build it, we put it in, we walk away. Maybe in 3 years' time there's an upgrade or an update that we have to deal with, and then we do that, and then we walk away again and we forget about it. These systems are not like that. If you're going to put in these kinds of systems and use them seriously, you need to be conscious that there's an additional investment that will be required to keep them up to date, to monitor them, and to keep a good eye on how they're working and functioning, and are they actually still functioning effectively for you. So this is another key one that you need to keep in mind. Number four is also a very important one to keep in mind. You know, I said to you at the front end that one of the big things that changed in this whole AI scenario in the 2000s was that we had increased computing power. You know, we had the ability to do some amazing things with computers. Compared to what was happening in the 80s, it was fairly primitive, right? And as time has gone by, what we've found is that computing power is actually pretty cheap. It's pretty cheap. In fact, most of the tools that you can use quite effectively for AI solutions are free. They're free. Facebook, Salesforce, all these guys, they've got massive tool sets. Python, anybody know what Python is? You know, programming language that is commonly used for some of these sorts of tools. There are Python libraries that you can access that have been written by people, and they are free. It's amazing, right? So the cost, as I put it, the cost to play is very low. You can get in and start to play. Some of you could go home tonight, watch a few YouTube videos, get a little bit of an understanding, and you could probably type up some Python scripts and actually do something, and you'd be amazed at what you could do for free. It's great, right? But the problem is, bearing in mind some of the other things that we talked about, once you get a solution in play and you want to productionize it, and then you want to keep it up to date, it starts to cost. And this is the trick, when you have these three sets of people, the vendors, the guy doing the work, the guy who's signing the checks, when there's a mismanagement of expectations around costs, boss, I only need 20,000 to go build the POC. Oh, it's great, take it, go do it. Then you come back and you say, we're going to need a lot, we're going to have 5 times that amount now to keep this thing going for the next 4 years. And he's like, whoa, you didn't tell me that. Now this thing's looking expensive. So this is the problem. And again, this is an expectation that's a really important one to keep in mind. When we've played around with some of our solutions, we found that people can actually spin up solutions really quickly, amazingly quickly. But then the next pieces of putting them into play and keeping them there actually can cost you a lot more. And that's an important thing to keep in mind. This one here is one of those costs, right? Number 5, don't think that all your data is helpful, okay? Most of us as mining companies have been collecting data for a long time. We have Pi historians or some other historian just collecting data. One of the beautiful things of the modern era in mining, and we've been talking about technology this way that technology is able to kind of really help us forward, is that every single machine that we have just about out there in the most harshest environment sometimes has hundreds of sensors on it, and they're all collecting data. They're collecting all this stuff and they're putting it away for us, and we think, oh man, we've got data. This should be good, right? But I can tell you from experience that sometimes working with your data to get it into shape, to make it usable, sometimes this is 80% of your project. We had a project in our business where we wanted to analyze our mine to mill data. So we have a very complex operation. Magnetite involves not just normally it's a type of iron ore. So this hematite iron ore basically is just as we call it in Australia, rusty dirt. You dig it up, sort of deal with it a little bit and chuck it on a train and off it goes, and you get your money, right? Magnetite's a little different. Magnetite, you have to get it out of the ground. It comes out of the ground at a very low quality. And then we have massive processing plants that will process and grind and separate the ore from the waste, and we do a whole bunch of this. By the time we finish, it's a high quality product, but there's an enormous amount of processing that goes on here. So we have a lot of data going on. So we thought, okay, this is fantastic. We just have years and years of data, sitting there for us to be able to look at what we planned when we blasted, all the way through to putting stuff on conveyor belts, to putting it through our 6 mills, and to magnetic separation systems and waste and product. We thought, man, we got so much data. We should be able to see some really cool stuff. And what we found is that for this project, literally about 80% of the project was given over to getting the data in a shape so that we could actually use it. The actual building of the model and the solution was very quick. Once they had the data, then it was just like, code up some stuff, use all those free products that are out there, do some stuff, run it over a couple of nights to try a few things, and boom, we had a solution. The next thing was to figure out how to, make that a operational kind of solution. But 80% of it, a full 80% of this whole endeavor was just getting the data together so that we could use it. So again, sometimes when we're talking about this, whether you're a vendor, you're the guy on the ground trying to work on this in a mining company, or the boss who's got to write the check, sometimes the expectations around what it's going to take to produce a solution were not always in alignment. This one is a very important one to keep in mind, because fundamentally, going back to what I said at the front, machine learning is all about data. It's the fuel for these solutions. So you need good data. If you have rubbish data, you get rubbish results, right? So you've got to get good data, and it's a very skillful job for people to work through this data piece and to get it right so that the solutions are actually good, accurate, and reliable, right? So keep this one in mind. The data problem is a huge one. Press the wrong button. There we go. Number 6 is a really key one, and it kind of ties into where we started, okay? Don't confuse clever computing with intelligence. I think it's really important to remember. We're hearing all this stuff about ChatGPT. One of the interesting things to me is that I've been seeing all these articles that are saying the skill of the future is prompt engineering. In other words, unless you know how to ask ChatGPT for the right thing, you won't get a good answer. And I think to myself, what is that telling us about ChatGPT? It's not that clever. I mean, if I'm talking to you and you ask me a dumb question, I'm not saying you will, but if you ask me a dumb question, I'd be sitting there going, okay, that's a weird question, but I think I know what you mean. Let me help you out with that, and I'll give you a good answer, right? But ChatGPT, it just says, it's a dumb question. Here, dumb answer, right? It's not that clever. And it's interesting to me that, one of the skill of the future we're being told in a lot of scientific articles is prompt engineering, right? But it's actually an important thing to pay attention to, is that, yes, ChatGPT and many of these other solutions that we build, they're very clever computing, but they're not intelligent. Now, there's a couple of reasons I tell you this. Number one is the expectations piece, to have good expectations of what you can and can't get. If you're expecting a sentient being to be on the other end of the line. That's a mistake, okay? Current machine learning models are not sentient, I can tell you now, from understanding the technology pretty closely. They're not sentient. They're not intelligent in the way that we are. The second reason I'll tell you this is that this is important because one of the key things that we're starting to see already in the press is people are going to lose their jobs. You know, the machines are coming. You know, the Terminators are coming. They're going to take over the mine, and all the poor people are going to be without work, you know? And I want to say, I just don't think this is going to happen. I don't think this is going to happen. In fact, fundamentally, I think artificial intelligence is a terrible name. I've argued for a long time that it should be augmented intelligence. My hunch is that AI, as we see it currently shaping up, it will work alongside us. There will be some jobs that go away, but they're probably jobs we want to go away, right? Jobs that are monotonous. In Australia, we have an expression. We call them the dirty, dull, and dangerous jobs, right? The 3 Ds. You know, the jobs that are dirty, where you're putting somebody into a space where it's just a horrible place to work. You know, let's take them away. Let's put a machine there. You know, the machine, who cares? Doesn't matter, right? Just does its thing. Dangerous jobs. If there's a place where we can replace a person with a machine in a dangerous space, that's a great idea. I'm happy for that job to go. Give it to the machine. You know, if it's a dull job where some guy's just dunk, 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 dunk all day long doing something really monotonous and boring, that's a bad job. We get rid of those jobs. Instead, we begin a journey of equipping people to maybe use the technology, some of these technologies more effectively, to have the technologies aid them in different types of jobs. And I think that's what we're going to see. Yes, it will take time, but I personally don't see this fear materializing that we're going to see massive loss of jobs and workforces displaced. I don't see it happening, and in fact, when you see some of the stats, I don't recall the exact numbers, but I've seen over the last 5 years, 6 years in particular, some of the stats or predictions, they're all slowly coming down, you know, where people said 70% of all jobs will be gone by 2030. You know, now it's like, you know, it went down to 50. Now I think one of the last ones is sort of down maybe 20% kind of number. And I think that's sort of realistic. And if you see that happening over a decade, that 20% of jobs go and they're replaced by different kind of jobs, I think that's actually sustainable, and we'll see a transformation of the workforce in a way. But that's the important thing to remember here, is that the computers will never replace us. I think ultimately they will aid us, they will help us. They will do some jobs maybe better than us. You know, if you're looking at real-time data streaming in very fast, and you need to identify patterns in a truck. You know, maybe you've got a truck that's pouring all this data off 100 sensors, and you want to be able to tell if there's a problem. And maybe there's 6 different sensors on this truck that tell you some interesting data, and they correlate. And when all 6 of those are saying something, you know, they're breaching certain kind of tolerances, you go, there's a problem, right? Now, a human finds this a very difficult job. You know, if you had a guy sitting in front of a screen looking at the matrix, you know, going on, and he's trying to figure out, oh, what's going on with the truck, he won't do it. The machine can do this perfectly. Most of the machine learning kind of techniques that we have could do this task effortlessly and really accurately and give you good results, right? So there are some things that are very narrowly defined that the machine will beat the human regularly. But when it comes to that fully integrated, holistic understanding of what's going on, that's a much broader problem. And right now, we are a very long way from AI even beginning to be able to tackle those types of things. And that's why I think I have great confidence that humans will still be in the loop, that we will be very much part of whatever's going on, because we bring a whole set of capacities to the game that really the computers do not, right? And it's an important thing for us to keep in mind. So let me wrap up there to say, I think basically this is a key time in history. We have really a very interesting opportunity ahead of us. There are a lot of things that can be done. AI offers some wonderful benefits. In our business, we've started to dabble with it, play with it, explore what is possible. I'm very excited because many of our vendors are bringing all kinds of solutions that have AI built into them. You know, we've been talking about cybersecurity. It's a great topic, a huge topic for us to keep in mind constantly, especially in mining, because we've probably been a little bit relaxed about this topic. But again, AI is one of the great parts of monitoring many of our systems. So many of the solutions that are being offered to help us deal with the AI challenge, they're employing AI type solutions to kind of monitor these systems and keep an eye on what's going on in the network traffic in ways that humans cannot do, right? So again, some really valuable stuff. We're seeing vendors who work in maintenance type areas, providing solutions that can see what's going on in some of our plant and equipment. For us, for instance, we deployed some machine health solutions a couple of years ago. I mean, we have these monster ultra-class trucks. If they have these electric motors on the four wheels, right? If one of those electric motors dies and goes up in flames, that's $500,000 right there, boom, right? And for a very minor investment, I can't even remember what it is, but it was very minor compared to $500,000. We've saved a number of events of that happening just by being able to monitor what's going on those trucks through some of the sensors and go, you know what, that truck's got problems. There's some temperature, some vibration. Let's get it up. Let's take a look at it. And we've been able to minimize those kinds of things. Massive value in those kinds of activities. Safety is another big area where we're seeing AI make a big difference. There's a lot of solutions involving, monitoring people to make sure they're wearing the right PPE, making sure people aren't going into places they shouldn't be going. It doesn't matter how many safety shares you have. There's always that guy who decides to climb into something you shouldn't be climbing into, And you just go, what are you thinking? But we're finding ways of using some of these technologies to monitor what's going on and to alert people that something's not right. And we can deal with those things very quickly. We're finding ways of using some of these technologies in terms of improving our production. And believe me, I mean, if we're not in a time of history now where there's so much demand and increasing demand for the kinds of products that mining produces to, make this battery electric world happen, we need to be good at production. We need to be super efficient. We need to be able to, produce more for less and really do that well. And certainly there's some AI solutions that are coming through that are, really offering some real game-changing possibilities. So I'm a very big proponent of AI. I'm a strong believer, and I think it has some huge value for us. But we need to be careful, and we need to really keep in mind some of these challenges. Otherwise, we go in, we try some stuff, it maybe doesn't go as well, and maybe we walk away and we don't tap into the full value because we either had poor expectations or suddenly it cost us much more than we thought, or there were some challenges that we could have anticipated, but we didn't. So I'm hoping that just maybe some of the things that we talked about today will help you with that. I'm going to be hanging around, but we have some questions. I'd be surprised if something I didn't say, if I did say today, would not have a question or two. So let me open it up. I'll let you guide me. If there's a question in Spanish, then we've got a problem. But I see it's in English, so this is good. Real quick question: what would you, when you say that we should underestimate the long investment, you think this is a current problem in the industry? I think it is, because I've seen a number of companies who probably didn't fully expect some of these solutions to cost as much as they did, not just in terms of money, but also in terms of people, because you need certain sets of skills to do some of this. You need to design your projects in certain kinds of ways where you need to get cross-functional involvement across your business in some of these projects to make them really succeed. And so there's investment, not just in dollars, but I think a longer investment in terms of getting people involved and having the right resources, the right talent. And I think a lot of companies go into these projects and they really don't think about those things. So yeah, I think it is a current problem. Second question, how should we close the data gap? Could you scroll up a teeny bit for me, please? So I can see the bottom of the question. Here we go. Oh, yes. Okay, look, the data gap, I think one thing that's happened is that in recent times, a lot of businesses have suddenly realized they're sitting on a lot of rubbish data, and that's not helpful. So I think one of the things is it's made companies a little bit more thoughtful about what they're storing, how they're storing it, thinking about actually the ways they might be using this, and trying to get the data to be clean at the front end, because having to do it afterwards is a very difficult job and takes a lot of time. And if you want to actually then productionize this, you really need to find ways of making sure the data that's coming to you from some of your equipment and stuff like that is actually clean and ready to use. So I think I've seen definitely some businesses starting to invest more time in that particular challenge, which is a very good thing. Data governance is crucial. And becoming, somebody already mentioned it in one of the earlier sessions, that the data governance, my colleague from Anglo American, data governance is huge because we're collecting so much data. Sometimes it's very difficult to figure out what's the source of truth. Where did this come from? Is it actually useful? What does this number actually mean? And so there's a lot of work that has to go into that. And certainly in our business, we've had a small team of people working on data governance, on data dictionaries, trying to figure out how we tidy up data so that it's understandable and usable and consumable for the business, and also secure, in some instances. So that's a big challenge. How can we measure the benefits to use AI in industries? Look, I think if I understand the question correctly, I think one of the reasons why AI is currently such a boom, such a buzzword, is because it is successful. It is. There's no doubt in my mind. It is making money for people, particularly in marketing, right? All these companies that use the AI technologies for basically taking personal data and using it to market products and stuff. It works, right? So I think definitely these techniques do work. I mentioned a few case studies a minute ago in terms of predictive maintenance, in terms of safety, in terms of production efficiencies, and some of these kinds of things, scheduling, and the holy grail of mining, short interval control. Where we've got so much data coming in, where we can be constantly monitoring on short cycles what's going on and where we need to adjust, not waiting for the end of a shift. 12 hours later we figure out, whoa, things are not good. Now we've got to work really hard for the next 12. We can actually be, maybe not minute by minute, but certainly I know at least one company hour by hour that they're reevaluating what's going on across their business so that they can make adjustments. So definitely there are a lot of great use cases that are there, being used in our industry already, but beyond our industry, definitely. This is why AI is still going, is because there's money in it. The current machine learning kind of trend is very, very prosperous, right? How do you see the impact of drone technologies? Well, look, I mean, for me, drones, I love drones. Drones are cool, right? Because they're just collecting data in a very interesting way that, wasn't really easily possible before. Whether it's geology data or whether it's construction type data, the ability to do flybys and actually, integrate that back into some of your sort of BIM type data where you can see what's going on, progress. You don't have to go driving around there to go see what's that pile of dirt now, what's going on there. You can see this all happening. Our mining operation, every day there's a guy who goes out there and he flies a drone around, sends it on a mission, and it goes around our pit and captures data and then brings it back, and they scan it all, and then they can tell what's been going on, provide very latest updates, match material moved with some of the other survey type data that they have to be able to make sure that some of their numbers and all of that is working well. So definitely drone data I love. And again, this is one of those ones where once if you wanted to own a drone, get the bank out, take a loan. But now you can go down to the store and buy yourself a cheap drone that costs like maybe a couple of $1,000 if you really want the expensive one. But you can buy as much cheaper ones to go do some of these jobs, and they're disposable almost. So this is what's very cool. Sensors are the same. We put sensors on some of our trucks. You want me to go? No? Okay, I'm still good. We put sensors on some of our trucks. Now, in years gone by, if you wanted to measure vibrations on a truck, and you'd go out and you'd buy some sensor that was very expensive, you put it on, and it was just a big job. We recently did a project, one of the projects that helped us with this whole exercise of saving our truck motors from burning out. We bought these sensors, they cost like $200, and you know how we put them on the truck? They have like super glue. It's just like, now we're off. We're taking data. And we're feeding it back through a Wi-Fi network, and it's going back across an LTE network back to our historians, and we're collecting all this. But $200. And you know what? If it falls off, let me go get another one. more super glue, you know, we're back in the game, right? So this is the cool thing about all this technology is the price point has dropped right back. Drones are the same. And I think drones is just one element of the broader robotics piece, the cyber physical systems that mining's been a bit slow on, I would say. You know, the whole, my German colleague here will have much more knowledge about the Industry 4.0 stuff. We talk about mining 4.0. But, you know, I know in Australia, sometimes we go, yeah, you know, we're like about a decade behind in terms of actually thinking about the impact of robotics. We have autonomous vehicles, yes, but in terms of really thinking about robotics and its full maybe deployment into some areas on mines, we really haven't grappled deeply with that. There's some companies that are experimenting, but I think all in all, there's just so much opportunity, and drones, like a lot of this stuff, is the price point is just coming right back, you know, so that it's very doable to experiment. One more question here. How, in your experience, what else should we include in a POC in order to reduce the gap between POC and the models in production? And that's a good question. I think one of the, I mean, you know, this, without trying to be too clever about it, I think actually probably one of the things to do is simply to go into the project thinking, if I have to operationalize this, what are some of the things I should be thinking about now, you know? In terms of, you know, I'm getting this data, and I'm starting to do things with it and build a model, and I'm going to do this. Okay, hang on, there's a lot of stuff going on here. How do I start to think about how this may be automated? And, you know, when you think about that early or begin to predict a little bit of what that journey is going to look like, I think you start to set more realistic expectations about what you're going to end up with. So that is probably part of it. But the truth is that I think the way we've tackled this, because in some ways it's very hard to know the full cost of what it's going to take, is in our business, and it's something I'll talk about tomorrow, is we experiment. So we use POCs as an experiment to test out value, and then when we see some good value, that's when I go to the CFO and say, I'd like more money, and we scope out the project a bit more robustly in terms of the next step, and we go into that then with our eyes open. There's a bigger cost, but we saw the value. So now we know that what the benefit is, what the cost is. We can make a good calculation and understand that. All right, I think that's all. A little bit of time, but thank you. Thanks very much.